We are going to finish up our unit here with section 8.3, and we're talking about a population proportion and the confidence intervals as they apply to population proportions. So first, just a reminder, the point estimate for the population proportion is p hat. And we remember that p hat is x divided by n. X is the number of individuals in the sample that have a specified characteristic, and then n is still the sample size as usual. Example 8.9. In July of 2008, a Quinnipiac University poll asked 1,783 registered voters nationwide whether they favored or opposed the death penalty for persons convicted of murder. Of the 1,783 registered voters, 1,123 were in favor. Obtain a point estimate for the proportion of registered voters nationwide who are in favor of the death penalty for persons convicted of murder, and then round our answer to 2 decimal places. So for this question, our point estimate, p hat, is just going to be the people who had the characteristic that they were in favor of that, 1,123, divided by the total number surveyed, 1,783. And when we divide that on our calculators, 1,123 divided by 1,783, and we round it 2 decimal places. Our proportion there, sample proportion, is 0.63. It's 6298, but that rounds off to be 0.63. So that would be our answer for example 8.9 here, finding that point estimate for proportion. The conditions for constructing a confidence interval about point P. If the criteria is satisfied below, then we can construct a confidence interval with a level of confidence 1 minus alpha times 100% for a simple random sample of size n. First, the sampling distribution of p hat is approximately normal if n times p times 1 minus p is greater than or equal to 10, and that's the same criteria that we saw back in chapter 7 when we were finding probabilities for proportions. Second, the sample size is small relative to the population size. Lowercase n is less than or equal to 0.05 times uppercase n. So the sample size is less than 5% of the population size. We also know that the mean, mu of p hat, is equal to p, and the standard deviation of p hat is equal to the square root of p times 1 minus p divided by n. So all of these things we saw back in chapter 7 when we were dealing with the sample proportions back in chapter 7. We saw all of these formulas and different criteria. So now suppose that a simple random sample of size n is taken from a population. A 1 minus alpha times 100 confidence interval is for p, is given by the following quantities. And notice what we're going to do. We're going to start with our point estimate, and we're going to subtract a little bit. Here's the little bit we're going to subtract, and then we're going to start with our point estimate again, and we're going to add that same value. So notice what we're doing is we're taking a z-score here, and we are going to multiply that z-score by our estimate of the standard deviation. We say it's an estimate because we don't know what p is. We just have p hat. We're trying to estimate p. And so that's where we're going to get our boundaries for our upper and lower bound. We do want to recall that n times p hat times 1 minus p hat has to be greater than or equal to 10, and n does need to be less than or equal to 0.05 n. Those conditions still need to be satisfied as we go through this process. Now, we do have some calculator steps for this on the TI 83s and 84s. Finding a confidence interval about P, press the stat key, highlight tests, and select option A, the 1 proportion Z interval. That is a proportion confidence interval, and using the Z-score. Number 2, enter the values of X and N. And then number 3, enter the confidence level following the C level blank there. And number 4, highlight, calculate, and press enter, and that will take care of it for us. For example 8.10, we're going to look back at example 8.9 and obtain a 90% confidence interval for the proportion of registered voters nationwide who are in favor of the death penalty for persons convicted of murder. And then the values that we are given here are from that example. 1,123 were in favor and 1,783 were the total number of registered voters. And we have already calculated in that example that p hat is equal to 0.63. So to find our lower bound, I'm going to do this by hand first, and then I'm going to show it to you on the calculator. To find our lower bound, we start with that 0.63, and then we're going to subtract this z sub alpha over 2. So I want to draw our picture here so we can visualize this just for a second, and then I'll probably have to erase it as I do the other part. But we want a 90% confidence interval, which means, and this is just a picture to visualize, that 90% of basically the stuff, the probability, the area inside of those two, in that confidence interval is going to be 0.9. That means 1 minus 0.9 is 0.1, and that's how much is left for these two outside spots. And that's the alpha. Alpha equals 0.1. And the reason that we do alpha divided by 2 is because it's split up into these two individual spots. So 0.05 will go over here, and 0.05 will go over here as well. So when we find this z sub alpha over 2, we're really starting and we're looking at this point, and we're going to find this value, and that's the z-score that we're looking for. So when we look at this area, we have 0.95 here, because it's the 0.05 plus the 0.9. It's this entire region as we enter this in, because our calculator is due to the left of our boundary point. So what we're going to do is, to find the z-score, we're going to go to second, variables. We're going to go down to inverse normal, because we're trying to find what that actual value is for our boundary. Inverse normal. Our area is 0.95. And since we're doing z-scores, this is a standard normal, which means the mean is 0 and the standard deviation is 1. That will always be the case when you're trying to find z-scores. So we're going to push paste and enter. And I'm going to use probably 3 decimal places here. So we find out that this z-score is 1.645. Okay, so that's the z-score. That's our z sub alpha over 2. And I'm going to underline that, and I'm going to erase everything else so we'll have a little bit of space. So again, back to our formula, p hat minus this z-score, 1.645, times, and then we have to do our square root of p hat, which is the 0.63, times 1 minus p hat, 0.63, whoops, 6, yeah, let's put that in there correctly. Divided by n, and n was the 1,783. So now I'm going to type this entire thing into the calculator, 0.63 minus 1.645, and then the square root of, and we're going to have 0.63, parentheses, 1 minus 0.63, close parentheses, and then we're going to divide by the 1,783. And that is our lower boundary. So our lower boundary here is 0.61. Okay, if we round off to 2 decimal places like we were asked to. Now the upper boundary, the really nice thing about the upper boundary is it is identical to this, except for this symbol right here, instead of being a plus sign, is a minus sign. So the easy way to do this is just go second, enter, and that brings this whole thing back up on the screen for us, and then we just go back to that minus sign, and instead of subtracting this value, we're now going to add that value, and then we hit enter, and our upper boundary is going to be 0.65 when we round that up, or round that off, 0.65. So a lot of times when we write this, we'll write it as a confidence interval with these boundaries like this, an open interval from 0.61 to 0.65, and that gives us our 90% confidence interval for this example. So that's doing it by hand. And again, we want to really get that idea of we're starting at p hat and we're subtracting a little bit and then we're adding a little bit to find that confidence interval. Here's how we would do it completely on the calculator. We go to stat, over to tests, and then we're going to go down to letter A, which is actually that one right there. 1 proportion z interval. And the x value, we just plug in 1,123, because that's the number of items or individuals that had that certain characteristic. The n value is the sample size, 1,783. And the confidence level is already 0.9 for 90%, so I don't have to change that one at all. And then we go to calculate. And notice it will give it to us in these parentheses. And here is our answer up there. Notice they also give us the p hat value if we hadn't already calculated that. But if we round it off to 2 decimal places, 0.61 and 0.65. And so in this case, even with our rounding, a little bit of rounding there, we come up with the same exact confidence interval for that 90%. Sometimes our rounding can cause us to have a little bit of error, but this one comes out exactly the same pretty much. So that's example 810. Example 811, in a survey funded by the University of Washington School of Medicine, 750 out of 1,000 adult Seattle residents say that they did not believe they could come down with a sexually transmitted infection, an STI. Construct a 95% confidence interval estimating the proportion of adult Seattle residents that do not believe that they can contract an STI, and then round your answer to 2 decimal places. So here are the values that we are interested in. 750 is going to be our X. That's the number of people that do not believe they can come down with that infection. 1,000 is the N value, that's the sample size, and then the confidence interval is the 95%. So when we do this on the calculator, stat, over to tests, and down to letter A, there it is. And this time we have 750, we have 1,000, and we're going to put in 0.95 for that 95% confidence interval and calculate. And so notice our confidence interval, round your answer to 2 decimal places it says. So our confidence interval is 0.23, or not 23, 0.72 and 0.78. And that's going to be our confidence interval, 95% confidence interval for that example. Now, one thing I'll mention is I know sometimes on the assignments, they will actually give you a p hat value. So let's say that they told us in this case, let's say we didn't know this, but they told us p hat was 0.7. So I'm changing the problem. Let's say they said p hat was 7. In order to put this into the calculator, we need the x value. So the way you get that x value is you're just going to take that 70%, basically, that proportion of 0.7, and multiply it by the n value of 1,000. And so for my example, that would be 700 people had that characteristic. So if you're not sure if they give you the p hat value and they don't give you the raw data number, that's how you can find that x value that you're looking for. As we had to do in our previous section, we also at times need to find out how large of a sample size we need to be able to come up with an accurate enough answer for what we're looking for. So the sample size needed for a specified margin of error and a level of confidence, 1 minus alpha, is given by this formula, n times p hat times 1 minus p hat, and then divided by z sub alpha over 2, not divided by, times z sub alpha over 2 divided by e, and then that quantity is squared. Where n is rounded up to the nearest whole number, again, we round up because we don't want to decrease our confidence at all. We would want to increase it, if anything. So if we have to round, we always round up. The problem that we have is that the formula uses p hat, and p hat depends on n, which is the sample size, and that is what we're trying to figure out. So we have a couple ways of working with that. The 2 ways of dealing with that are, since our formula uses p hat, The two options are, one, we can use an estimate of p hat based on a pilot study or an earlier study. And so we can use some old information as our p hat. Or if you aren't given any old information, the other option is you let p hat equal 0.5, and that gives you the largest possible value of n. So if your chances are 50-50, if your portion is 50% and 50%, have the characteristic and do not, that gives you your largest possible value of n. And so if you don't have any other options, that's what you would choose for your p hat value in a case like this. For example, 812, we've got a sociologist wants to determine the percentage of residents in America that only speak English at home. What sample size should be obtained if the sociologist wishes that the estimate is within 3 percentage points of 90% confidence, assuming that the sociologist uses the estimate obtained from the Census 2000 supplementary survey of 82.4. So the first thing we know is that our p hat that we're going to use in this is going to be 0.824. We take that percentage and change it to a decimal. That is from a previous study, so we don't have to estimate with the 0.5. So 0.824. And we're trying to find our n value based on that formula. So our formula, remember, says n equals p hat 0.824 times 1 minus p hat 1 minus 0.824 times, now we need the z-score again. So I'm going to, now we need the z-score again for the top, so I'll come back to that in a minute. And then we're going to have this fraction is squared, and the bottom number is going to be this 3 percentage points, the amount of error. And since that is a percentage, we do want to put it in as 0.03. And then we want a 90% confidence interval. So again, if I draw a little picture over here, and remember the idea is 90% of our area is in the middle there, and we already looked at this. This is the exact same one we had before. That means 0.05 is over here and 0.05 is over here. And we're trying to find this z-score, z sub alpha over 2. And again, the reason it's alpha over 2 is because your alpha, your outside area, is split into those two parts. So this is actually the exact same one. So when we go over here, we're going to probably get it pretty quickly. Second variables, whoops, why is this not on? There we go. Second variables, inverse normal, and this is the one we want. Notice 0.95 of our area, that is our area over to the left. And so that's the area we've got. This is a standard normal because we're finding a z-score. So the mean is 0, the standard deviation is 1, and we go to paste. And so this is going to be our same number that we had before, 1.645. So let's go ahead and type this into our calculator now to get the number of our sample size, the sample size. 0.824. Parentheses 1 minus 0.824, close the parentheses, and then parentheses 1.645 divided by 0.03, close the parentheses, and square it. And we hit enter, and we come up with that number, 436.04. And remember, the key thing here, we always have to round up. If we round down to 436, we're not quite at that 90% confidence level. So we want to round up to 437. And that will give us a little bit more than the 90% confidence level, but that is better than less than 90% because we want to be at least 90% confident in that 90% confidence level. That is the end of section 8.3. You've got 3 graded problems. They do have multiple parts to them. So again, if you get stuck, please make sure that you contact me and ask questions if you can't find the answer on your own.